Alright, so we don't have anything that cancels in the top or the bottom, therefore we don't have any holes. Again, it doesn't matter at this point what order you guys go in. I'll just go in order, but it does not matter. You don't have to do one before the other except for that first step. Okay, so y-intercept is when the x value is 0. So let's plug in 0 for x. 0 cubed over, it doesn't even matter. 0 divided by anything is going to be 0. So when we plugged in 0 for x, we got out 0 for y. Now that also happens to be the x-intercept, which is y on your homework yesterday. It just said intercept because it was the x and the y-intercept. If your y-intercept is 0, 0, then that's also the x-intercept because that's where it hits the y-axis and the x-axis. Vertical asymptote is when the denominator equals 0. So if we set each of these factors equal to 0, we get x equals -1 and x equals +1. Make our vertical asymptotes there. When the degree of your numerator is exactly 1 bigger than the degree of your denominator, that's when we get a slant asymptote. If you have a slant asymptote, you cannot have a horizontal asymptote. It's one or the other. You can't have both. Okay, so because we have slant asymptote, there's no horizontal asymptote. So let's find the equation of that slant asymptote by performing long division. So we're going to do x cubed divided by x squared minus 1. I am going to add in placeholders, x squared plus 0, x plus 0. If you guys want to do it without those, you can, but just to keep things clear. So x squared times x will give us x cubed. So that gives us x cubed minus 1x. But we need to change the signs. So that's minus plus, and then we add. 0x cubed, 0x squared, 1x, and we can bring down the 0. So how do we go from x squared to x? Well, we're done. That's my remainder. The remainder does not matter. When you're getting the line of your slant asymptote, we do not care about the remainder. It's insignificant. And therefore, the slant asymptote is y equals x. This is in slope-intercept form, which is really y equals 1x plus 0. So if we're going to graph this line, our y-intercept is at 0, and then our slope is positive 1. So up 1 over 1, and so on. Down 1 over 1, and then we can make our slant asymptote. And remember, rise over run. So up 1 over 1. So again, remainder does not matter when you are finding the equation of your slant asymptote. All right, so let's pick points that are to the left and the right of our asymptotes. So that would be -2, and then 0, but we already know where the point is at 0, so we don't need to plug that in again. And then +2. But since we're not, right now, all we have between our two asymptotes is a point at 0, 0. Is that enough information to tell me what is going on there? No. So we need to pick additional points to figure out what my function's doing. So let's plug in -1/2 and +1/2 as well, so we can see what's actually happening there. Okay, where do you plug it in? It's really up to you. You could plug it into the original one or the simplified one. In this case, I actually think the original function might be easier, but that's really up to you. Usually the simplified one is easier, so it's up to you. But I'm going to plug it into these numbers into the original. So we have -2 cubed over -2 squared minus 1. You don't have to show this work if you're able to do it in your head, but sometimes it's easy to make mistakes if you don't write it down. So that's up to you. So we have -8 over 4 minus 1, which is 3. All right, let's take -1/2 and square it. Or sorry, -1/2 and plug it in. So -1/2 cubed is -1/8. And then negative 1/2 squared is positive 1/4 minus 1. So that's really negative 3/4. And then when we're dividing by a fraction, did I say negative 3/4? Yeah. When we're dividing by a fraction, we're really multiplying by the reciprocal. So we have negative 1/8 times the reciprocal, which is negative 4/3. So we get a positive 4 over 24, which simplifies to 1/6. If we make this positive, then we get positive 1/8 over 1/4 minus 1. So, or wait, hang on. Positive, so it's 1/4 minus 1. So again, that's negative 3/4. And so then we have positive 1/8 times, again, the reciprocal, negative 4/3. So this time we just get a negative 1/6. And that does happen quite often, not all the time, but for specific functions it does. Okay. Now let's plug in 2. Alright, 2 cubed is 8 over 2 squared is 4 minus 1 is 3. So there we go, we got the positive 8. Alright, so let's plot those points. Negative 2 and 2/3. So negative 2.6 ish. So that is, oh. Okay, it just keeps disconnecting and reconnecting, so. Right here, negative 1/2 up 1/6, and then over 1 down 1/6. So that is going to follow the asymptotes and look like this. It's not going to go over. My marker's just, my board is not being very happy right now. And then 2 up 2.6. It's about here. That's going to look like that. Again, this one did cross our slant asymptote, and that's okay. It's just never going to cross our vertical asymptote. Questions on first example? All right, second. Told my board last. Doesn't look very happy right now, so that's unfortunate. Okay. Simplify first. See if there's any holes. When you have 4 terms, you want to factor by grouping. So in the first 2 terms, my GCF is x squared. So we're left with 2. Yep. X squared, so we're left with 2x plus 1. And then the GCF in my second group, we don't want a negative third term, so we need to pull that out. So that is a GCF of negative 4, and we're left with 2x plus 1. So then we get x squared minus 4 times 2x plus 1. What we're doing there is pulling out our GCF of 2x plus 1. I should have written that one first, but it doesn't matter. We're multiplying, and we're left with x squared minus 4. And x squared minus 4 factors. That factors to x plus 2 times x minus 2. And then we still have times 2x plus 1. So there's our numerator. Over our denominator, which factors as well. So my denominator factors to x minus 2 times x minus 1. And we have a factor of x minus 2 cancel on the top and the bottom, which means there's a hole at positive 2. Okay, so the factor is x minus 2. That means the x value of the hole is at positive 2. So then we can plug in 2 to get y. You can either plug it into the original function, which here looks like a lot of work, or you can plug it into the simplified function. So we cancel these out. I'm not going to rewrite it, but we're going to plug it into our simplified function. So when we plug in 2, we get 4 times 5 is 20 over 1. So 20 divided by 1 is 20. That's going to be way off our graph, yeah. Yep. Yeah.
third graph, you'll have to make each
by like 3, yeah, yep. I'm not going to, but y-intercept, we'll plug in 0 for x. So we get 2 times 1, that's 2, over -1, -2. Y-intercept. This is really going in and out. Just be patient. That's what it was doing all last period. You know, you can hear the sound disconnecting, reconnecting. All right, x-intercept is when we set the numerator equal to 0. So if you take each of these factors and set them equal to 0, we get an x-intercept at -2. And then we subtract 1 and divide by 2, so we get an x-intercept at -1/2. Yeah?
Okay, I keep getting mixed up, so how do you find the y-intercept again?
Yep.
Right.
So think about the y-intercept. What can you tell me about the x value?
It's going to be 0.
Yep, so you plug in 0 for x.
Oh,
Yep.
that's what I do.
Yep, and then what can you tell me about the x-intercept?
The y value is 0.
Exactly. So technically what we're doing, and if you forget the rule, you can just plug in 0 for y. And what happens is when you plug in 0 for y, you take the denominator and multiply it over, and it equals 0 anyways. So then you get 0 equals the numerator, which is why we just say set your numerator equals 0.
Okay.
Yeah. Vertical asymptotes are what's going to make the denominator equal to 0. So set the denominator equal to 0, and we get x equals 1. Okay. And then our slant asymptote, we're going to do long division. So why don't you guys do that while I recalibrate this again.
Use the denominator.
Okay, atom 7x squared minus 12x. And then multiply by 7. We get 7x squared minus 21, so turn it to plus 21. And positive 14, so it's going to be minus 14. And we get 9x minus 18. But a remainder does not matter. So here's our line, y equals 2x plus 7. Why did we have a slant asymptote to begin with? Because the degree in our numerator was exactly 1 greater than the degree in the denominator. If it's like x to the 4th over x squared, there's just no horizontal asymptote or slant asymptote. If it's right, but if it's exactly 1 higher, that's when it matters. If it's higher, there's no asymptote. If it's exactly 1 higher, there's a slant asymptote. So again, because there's a slant asymptote, we can't have a horizontal asymptote. This has a y-intercept at 7. So that's up here. And then our slope is positive 2, so it's going to look like this. So we'll go down 2 over 1, down 2 over 1, down 2 over 1. And then we'll graph our slant asymptote. That was not a great line, but here's better. X equals 1 is our vertical asymptote, so let's get that in here. We got our y-intercept at 0, -2. So let's graph So we already graphed 1 to the left is our y-intercept, and 1 to the right is 220. We already have that point because it's our hole. So when x is 2, it's 20, so I'll show you what's going to happen up there. So over here, let's plug in, I don't know, we can plug in a -1 and maybe a -2. Let's do -1 and then see if we need to plug in -2. So when we plug in -1, we get 1 times -1 is -1. -1 over -2 is +1. So -1, +1/2. And then let's also plug in -2. Likely it's just going to go up and then follow the asymptote, but why not plug in another one? So that's 0 times, it doesn't matter. So it's going to be 0 divided by, it doesn't matter. So it's 0. Okay, so we're right. It's just going to follow the asymptotes. It goes up that high, and then there we go. So up here, 220 would be all the way up here. The asymptote, that's going to keep going, that's going to keep going. There's a hole at 220, and then it's just going to follow the asymptote. So you guys have seen that before. It's just, that's way up there. Okay.
I don't have to drop that way up there.
No. Nope. You won't have one on your, you won't have one. This is the only one that's going to do that. Yeah, so you're good. All right, that's it.